There is a formula that we call quadratic formula. You guys have seen it before. You guys have seen it before, then let me remind you guys of the formula. And it has like x is equal to, and then it has like negative b plus or minus the square root of b squared minus 4ac all over 2a. And where does the letters a, b, and c come from? Well, given a trinomial, let's say something like 3x squared plus 4x minus 3, something like that. The numbered in front of the x squared, that's our a. So this value will be my a. The numbered in front of the x, I'm highlighting the sign as well. This number will be my b. And lastly, let the numbered by itself at the very end, that will be my C. So in this case, my A is positive 3, my B is positive 4, and my C is negative 3. So that is what we call the quadratic formula. We will be looking at the quadratic formula soon, but for now, I just want us to focus on the part of the formula that we call the discriminant. Now, the discriminant, let me highlight, is the square root part. So I'm only going to be looking at the square root of b squared minus 4ac. On top of that, I'm just going to look at the inside of the square root. So having that said, I'm looking at just b squared minus 4ac. That's all I'm going to be looking at when I say the discriminant. I'm just focusing on b squared minus 4ac. The instructions for today said, find the discriminant of each quadratic equation, then state the numbered and type of solutions. Okay, so let's see. Again, I'm just focused on the discriminant, looking at my equation. First of all, I have to have my trinomial here. It has to equal to 0, so the right side has to be equal to 0. So this is what I have. According to my trinomial, my A value is negative 6, my B value is positive 1, and my C value is positive 1. Where did I get those values? There's my A value, the one in front of the B, it's a 1B, so that's my B value. And then my number at the very end, positive 1, that's my C value. The variable, in this case, is B. It could be A, it could be R, it could be any letter that we want to write. So I got my A, my B, and my C value. Again, I'm going to use this for my discriminant. So let me rewrite this. B squared minus 4AC, let me replace it with the letters that I have. So let me call this 1 squared minus 4 times a negative 6 times a 1. I replace my values of B, A, and C. Okay, so I'm going to do a couple of things. First thing I'm going to do is my exponent by itself. 1 squared. 1 times 1. Well, that's 1. And then the second thing I'm going to do is this whole thing together. Notice how I highlighted the signs as well. What I'm going to do first thing is focus on the signs, the negative signs. In this case, I have a negative sign there and a negative sign there. If my amount of negative signs is even, which is my case here, because I have 2 negative signs, if the amount of signs is even, I'm going to write it as a plus sign. If the amount of negatives is an odd amount, so let's say I had 3 negative signs, my sign will be minus. So let me say that again. If the amount of negatives is even, write it as a plus. If the amount of negatives is an odd number, write it as a minus. And then let me multiply my numbers. 4 times 6 times 1. I know 4 times 6 is 24, and 24 times 1 is still 24. Now, to finish this, my discriminant in this case will be 25, right? 1 plus 24, that's 25. So that is my discriminant, because the first thing is find the discriminant. There you go, 25. That's my first answer. And then I'm going to have choices, whether I have one real solution, two real solutions, or one imaginary solutions or two imaginary solutions. Now, let me ask you guys this. If I asked you for the square root of 25, if I ask you guys for that, the square root of 25, how many answers can you have for that? Well, some of you might say, well, positive or negative 5, right? Positive or negative 5. Okay. When we have the square root of a positive value, in this case, positive 25, I'm going to have two real solutions. Because if I was to ask you the square root of 25, you come out with two possible answers. Now, what makes it a real solution and an imaginary solution? A real solution, what makes it a real solution is that I could get a number line. There's a 0, there's a positive 5, a negative 5. I can find my solutions on the number line. That's what makes it a real solution. Okay. 0 is also a real solution if my answer happened to be 0. So let me just say this. These are going to be possible choices that you guys get. Your discriminant, the discriminant could either be positive, 0, or negative. If I get my discriminant to be a positive value, like it was my case, I'm going to have two real solutions. If my discriminant is 0, we're going to see that happen sometimes, I'm going to get one real solution. You might be like, why is that? Well, if I asked you, what's the square root of 0? And then you got some people might come and say, well, positive or negative 0. But isn't positive or negative 0 the same number? It's still 0. Can you plot it in the number line? Yes. So it is one solution and it is real because we can plot it in. So again, if my discriminant is positive, it doesn't matter if my discriminant is a perfect square, just positive, I get two real solutions. If my discriminant is 0, I get one real solution. Now, if my discriminant is negative, I'm gonna get two imaginary solutions. What if I asked you, can I possibly ask you what's the square root of a negative 9? I know the square root of 9 is positive or negative 3. But what is the square root of negative 9? And then if we search for this, it's going to be positive or negative 3i. And I stands for imaginary. And yes, we're going to be able to get square roots of negative numbers as long as we use imaginary values. So my discriminant is negative. My answer will be two imaginary solutions. All right, let's practice a little bit more here. First of all, I checked that I have my polynomial there. It is equal to 0. Based on that, I'm going to have that my a value is negative 8, my b value is negative 1, and my c value is negative 4. And you guys can see where I got them. There's my a value, my b value, and my c value. Because I remember the discriminant formula, b squared minus 4 times a times c. Because b is negative 1, let me write it all inside parentheses. So negative 1 minus 4 times a negative 8 times a negative 4. I replace my values of b, a, and c. First thing I'm going to do is my exponent. What's negative 1 times negative 1? Well, positive 1. Second thing I'm going to do is pay attention to all of this combined. Look at the negative signs. I have 3 of them. 3 is an odd number, so I'm going to put this as a minus. And then let me multiply my numbers. So 4 times 8 times 4. I know 4 times 8 is 32, and 32 times 4 is 128. Now, to find my discriminant, basically I'm asking what is 1 minus 128? And my answer will be negative 127. That is my discriminant. Because my discriminant is negative, I'm going to have 2, let me write this all in letters, 2 imaginary solutions. The square root of a negative number will give me imaginary solutions. Okay, let's take a look at a couple more examples. For number 27, I can see this is my A value. Here I see my B value, and here I see my C value. So my A is 4, my B is negative 4, and my C is positive 1. Now remember, the formula for discriminant is B squared minus 4 times A times C. So I'm looking at this as negative 4 all squared minus 4 times 1. First thing I'd look at is my exponent, negative 4 squared. So negative 4 times negative 4 is positive 16. Then I look at my second part. I look at how many negative signs I have. I have 1 negative sign. That's an odd number. So because it's an odd number, I'm going to put it as a minus. If it was an even number, I would have put it as a plus. I multiply my numbers. 4 times 4 times 1. 4 times 4 times 1 is 16. Now to find my discriminant, 16 minus 16, my discriminant happens to be 0. When I get my discriminant to be 0, that's going to give me 1 real solution. Remember, when your discriminant is positive, you get 2 real solutions. When your discriminant is negative, you get 2 imaginary solutions. When your discriminant is 0, you get 1 real solution. So let's take a look at number 28. I see my A value here, my B value is right here, and my C value, it's right there. So I'm going to say my A is negative 2, my B is negative 2, and my C is negative 2. Now remember the formula, B squared minus 4 times A times C. So negative 2 all squared minus 4 times a negative 2 times a negative 2. Let me start with my exponent. Negative 2 times negative 2 is positive 4. Let me take a look at my second part. I count the negative signs. I see 3 of them. I know 3 is an odd number, so let me write this as a minus. Let me multiply my numbers. 4 times 2 times 2. Now 4 times 2 times 2 is 16. For me to find my discriminant, I do 4 minus 16. My discriminant is negative 12. Because my discriminant is negative, I'm going to get 2 imaginary solutions.